Okay, how we doing? We got today's tactical technician videos about Honda Shift Interlock, which is a system many cars use. I would guess I'd call it a safety system. For many years, I had a hard time understanding this system because I didn't really understand it until I hooked a scope up to it. Then it became a lot more clear how it worked. This system was put on cars, I don't know, I guess back in the 80s when this Audi 5000 had issues that the car was running away on startup. So in order to mitigate a problem like that, all cars utilized an interlock system. Basically, you have to have your foot on the brake to get out of park. That's the Shift Interlock solenoid there. You can see that. We're going to clamp that. We're going to look at it on the scope. We also have a key interlock solenoid. That prevents the key from coming out unless the car is in park. So anyway, we have 8 channels here. We're going to go through one at a time. Channel A is a current clamp around the key interlock solenoid. Channel B is a current clamp around the shift lock solenoid. Channel C is a channel at the key switch, which is an input to the multiplex integrated control unit. Channel D is a brake switch input to the MICU. Channel E, purple, is also a brake switch to the PCM. Channel F is a park switch. It's kind of a switch input whether the car is in park or not. And that is also channel G, orange, it's whether the car is in park or out of park. Channel H, burgundy, is the park pin switch. And that's the one I really want to kind of talk about. That's the switch in the center on the shifter. It's got that button in which your left thumb pushes down to activate basically the MICU, which is a control unit, multiplex integrated control unit, which is integral with the under-dash fuse relay box. That sends an input that the MIC knows that, and the MICU will do something with that information. It will actually power up the key interlock solenoid. The key interlock solenoid is a safety feature that will prevent the key from coming out unless the car is in park. So the park pin switch has 2 positions. In the open position, that would imply the button. When the open position, that means the shifter is in park. In the closed position, right there, that means it is out of park or the button is pushed in. So basically, we're going to look at everything on the scope, and I will go through each switch. We'll kind of do it like a 3 count on each of the individual inputs to get an idea what they look like. And anyway, I will go to the scope. We're running across the scope, and we can look at our channels. We've got our 8 channels here, and let's get it. Okay. Okay, basically, we're hooked in. What I'm going to do is take a look at your schematic, and I'm going to do one at a time. I'm going to do a 3 count on each input, and then we'll kind of come back to the scope. We'll stop the scope and kind of roll it back and take a look at each of them. One, I'll do the key switch 3 times. Then I'll do the brake switch 3 times. Then I'll do the park pin switch 3 times. And then I'll do the trans range switch in and out of park 3 times. So I'm going over to the car. I'll do each in sequence, opening the door. Okay, and here we go. Okay, park pin switch, 1, 2, 3. Brake switch, 1, 2, 3. Now I'll do the 1, 2, 3. That is the park pin switch. Now we'll go down on the brake, and I'll do park, out of park, park, out of park, park, out of park, back in park. And the key off, and let's talk about it. Okay, I'll stop the scope and roll it back to the first capture. As you can see, here we go, down the line. Okay, right here I started. Green is the 3 on the key switch. You see the key switch. Basically, it's a wake up to the MICU. Black and purple. You can see them right here. We'll kind of zoom in on those. That's the brake switch right here. I'm on the brake, off the brake, the 3 times there. Keeping your eyes on your schematic. The next one is the park pin switch. That's the burgundy. You can see when the voltage is low, that means I'm on the switch. You can see that it's a ground side switch. So you can see right here the volt. That's when I pressed the switch in, and the voltage went low at the park pin switch. I did that 3 times, and the next one is the transmission range switch. That's when I came in and out 3 times. That is gray and orange. You can see it right here. We'll zoom in on it. That's a power side switch. So that's on the brake right here, off the brake here, on the brake here. And that is the brake switch. I will talk about the solenoids. Let's talk the solenoids one at a time. I'll go back. We're going to start with the shift solenoid, which is channel blue. And we got some action right here. When the brake switch is down, which would be the black and the purple, that would give the multiplex indicator control unit and the PCM information, and the PCM will ground side switch the shift lock solenoid. So let's look at that, and we can see right here, we can see the brake switch down. Because our black channel's high, which is the brake input on black here, and on purple here, we're high. That's the current going through the solenoid. So basically the brake switch is down, and the red is the shift interlock solenoid. You see, it's got a good pintle hump. That is the second channel on the scope. You can see current flowing through the shift interlock solenoid, and with that being done, I'm able to move the shifter out of park. So we can look at our orange and our gray, and they start to go low, which would imply that they start to go high. With them going high, that would imply that I'm out of park, because the park neutral switch basically is open. So that's high on orange and high on gray. That means I am out of park, because the solenoid gave me the allowance, the green light to do that. And you can see that when I go out of park, the solenoid will stop flowing current. That's right here. For some reason, it doesn't seem to have to lock you in there, because you're already out of there. So I go back into park right here. You can see the orange go low and the gray go low. That means I'm back in park. Let's zoom in on that. Okay, the gray is low and the orange is low. So I'm back in park, and we got current flowing through the shift interlock solenoid, allowing me to go back to, if I want to get out of park, I'm able to, because my foot is on the brake, because black is high, and our other brake input, purple, is high. So we can see that. Let me bring that guy down. Yeah, you can see that the purple guy is at full voltage right here. So basically the current flowing through and allows me to come out of park if I want. So I'm going to go back and we're going to go live, and I'm going to do one more thing. I want to see the situation. I want to talk more about that key interlock solenoid and how that thing works. So basically, let me go back in, and I will activate the key interlock solenoid by pushing the park pin switch in. So we'll just kind of watch those two and talk about it. Okay, do that 10 times so we can talk about that action reaction. I'm just going to focus in on that, and we'll see what how that thing is. The thing that initiates the okay, we're just talking about basically an input and an output here. Just if you look at your schematic, we're going to talk about burgundy, which is the channel H, and we're going to talk about channel 1A. This is the park pin switch. When I push the park pin switch in, okay, that means the MICU will power side switch the key interlock solenoid. There's a definitely really even relationship here between those two. So the MICU is powering the solenoid when the park pin switch is in. That voltage is going low. That's our current to the key interlock solenoid. So anyway, just take a look at that. You can see the relationship between those. Now I'm going to go back and I want to do just a kind of like this, but I want to do a relationship between the brake switch and the shift interlock and kind of watch that action reaction. So I'm in. Okay. Key in, key on. I'm going to do the brake a couple of times. Okay. Key off and we'll talk about it. Okay, this is action reaction. This is the brake switch and the shift solenoid. So let's go back to here. Okay, here we have a good picture of it. Red is the current flowing through the shift interlock solenoid. It's right in line with the brake switch. Look at that. You can see the pedal hump on the solenoid, and right here, black and purple are our brake switch. So definitely there's a relationship between the brake switch and the shift interlock solenoid. So anyway, I will go back, and now I'm going to roll one more capture where I'm going to do pretty much a mixed bag of I'm going to try to catch everything in a couple of screenshots, and we'll kind of talk about it. So anyway, I will go to the car and do it, and then we'll talk about it. First thing I want to talk about is the key interlock solenoid. The key interlock solenoid, I'll watch it in action. I'm down on the brake, key is in, key is out, key goes on, shifter goes park, drive, back to park, back, now I'm in drive. Now I'm in drive, key is on. Okay, I want to get the key out. I can't get the key out. Try a few times, I can't get the key out. Okay, I step on the brake, still can't get the key out. Go back to park, now the key comes out. Okay, so let's analyze that. Okay, go back to the first capture, and you see my green, that's me putting the key in and out. Okay, my next deal is stepping on the brake. I stepped on the brake first. That's right here. You can see the black and the purple. Look at your schematic. I'm on the brake. I move the key in and out. I push the button in on the shifter, the park pin switch. Right here you can see the current goes through the solenoid. The solenoid is giving me the green light here. It's flowing current. Right here, it's letting me come out of park whenever I'm ready. So right here is when I come out of park. Here's the orange and the gray. Voltage going high. That means I'm out of park. The solenoid stops flowing. Right here, I go back into park, and the current starts flowing again. So as I go down the line, we'll talk about the blue channel, which is right here. That's the current flowing through the key interlock solenoid. You can see that. And when current's flowing through there and the transmission range switch is outside of park, that means you'd have a high voltage on orange and a high voltage on gray, as you can see. Okay, right here. And that means I'm out of park and I can't get the and the current is flowing through the interlock solenoid. Okay, that means I can't get the key back out because I have to go back into park. So right here I go back into park, and okay, right here. Okay, let me get that sequence again. I'm just trying to get my bearings here. This is the current flowing through the shift interlock solenoid. This is blue. Okay, that prevents the key from coming back unless we're in park. So on orange and gray, we are out of park, and we got the solenoid working, and for some reason, let me run that again. I'm just going to go into another capture, and I'm just going to concentrate on the key interlock solenoid. Okay. Okay, down on the brake, key on, shifter out, I'm in drive, I'm in park. See that? I'm just working on the button. Out of park. Key won't come back. Won't come back. I go into park. And the key comes back. So let's take a look at that. Okay. So we want to let her stop, and then we'll analyze the key interlock solenoid. Okay, go back to the first capture. Okay, so right here we started with my foot on I stepped on the brake right here. That is the black and the purple. I hit the button for the park pin switch, which would make it go low on burgundy. That's what powered up the key interlock solenoid. Right when I hit the park pin switch, the key interlock solenoid started to flow current. And then I got to my next spot right here, and we can see the relationship between the park pin switch and the key interlock solenoid as we're going down the line. And then I'm off the brake, and then what happens here, I'm on the brake, I get back on the brake because black and purple go high. The solenoid allows me to come out of park if I'd want to. The park pin switch is closed. When the park pin switch is closed, there's current flowing through the key interlock solenoid, and right here I come back. You can see on gray. Let's concentrate on gray and orange right here. Gray and orange would imply that I'm back in park. Once I'm back in park, the solenoid, so the blue solenoid, it stops flowing current. So I'm able to pull the key out. So you can see there's a relationship here of I have to be in park for the solenoid to actually stop flowing current. Once as the name implies, it's a locked solenoid, so it locks the key from coming back out when I am not in park. So right here, I go to park, and then the solenoid stops, the MICU stops powering the solenoid, and I'm able to pull the key out. And so anyway, we just look at a few more things here. I know it's been a lot of channels and a pretty much a challenging video even on my part, but nonetheless, this system's about action, reaction, and you don't have to hook up obviously 8 channels every time you're dealing with one. But if you have one that's giving you trouble, always remember the scope is really powerful to see that action reaction. You can validate that your solenoids are moving, and it probably is one of the better ways to do it. Yeah, hookup time is a variable, and obviously you want to think about that. Easiest places to get the wires, and I just want to show you where I'm set up before I end the video, because it's probably wondering where the clamps are. There's the PCM, there's an amp clamp, and there's the burgundy channel, the actual purple channel, which is a transmission range input, the orange channel, which is also a range input. So purple and orange, we know are inputs to the, I'm sorry, one's for the brake and one's for the transmission range. On the other side of the car, I am at the multiplex integrated control unit, which is right here with another clamp and a bunch of hookups here. Can you see that? That's basically where I am. So